Welcome back, my dear students. This is the video number 3 in our Math 146. So I will just share the screen, start from where I stopped, then we will complete, we'll go ahead and check out our work. Okay. This is the proportion, which I said in the last class, how to do the proportions. And let me give another example quickly so that it will be very clear for you guys. Let me give an example how it will work. Like, let me say y by 7 equals, let's say 4 by 2. Okay, then we'll do the Caesar work. Okay, that means that 4 multiplied 7 equals 2 multiplied y. 4 by 7 will give me 28. And 2 by y, this is by, like I can do it like this as well. So that will be 2 by y means 2y. 2y. Okay. Then how I'll get the y? Y equals, the far from the y is the 28 divided by the stuck to the y, which is 2, right? This will give me 28 by 2. 28 by 2 will give me 14. And this is the final solve of the problem. Again, 2y equals 28. Then 1y will be 28 by 2. You got 2 kilos of, an example, banana for $28, or 2 kilos of apple, or whatever, 2 kilos, 2 things with $28. Then each one of them will be 28 divided by 2 will give you $14 for each. And this is the solve of the problem. Okay, let's go now to the share the screen back. Then we'll see what comes next in this. Okay, this is another scenery of when we see here, this is the same thing. Solve the proportion 2 by 5. This is the same example which I gave you just now. One example like this. And this is another example. I can stop for 1 minute for you to train yourself. So this is 2 by x. 2x equals 5 by 8, means 42x equals 40, then x will equal 20. And this is another example. I can stop for 1 minute, please, and you can train yourself. Just write it down. Write down the example, the cross multiply. We call it cross multiply. This is called cross multiply. Okay? I'll give a pause 1 second for you just to do it. Okay. Now let's go back to another page, which should be here. I'll stop sharing for 1 second, then we'll come back. This is the proportion. This is example number 2. This is page number 3. That's fine. Okay, this is another example, like x divided by 5. I will stop share and do it. It's the same one. Why don't you do it with your own hand? X by 5 equals 7 by 35. I'll give you 1 minute to do it, please. Please do it. Here we go. x by 5 equals 7 by 35. Sorry, I was not just putting the share, but now it's sharing. X divided by 5 equals 7 divided by 35. It's the same idea. X by 5 equals 7 by 35. Then use the cross multiply. You will divide x by 35 equals 5 by 7. So 35x will equal 35. Then x will equal the far, which is 35, to the nearby the x, which is 35. 35 by 35 will equal real 1. Let me solve it on the board and show it to you when we solve it on the board, how it will look like. It's the same idea like this one exactly, the same idea. X by 5 equals 7 to 35. Well, okay, I will translate it. Now, we'll see here. It is x by 5 equals 7 by 35. Okay, I can change it into this form. Denominator and denominator. X by 5. X 2 dots 5. It equals this form. Equals 7 divided by 35. Great. Then multiple crossing will be 7 by 5 will equals 35. When you do the Caesar, equals 35x. 35 by x, 35x. Then x will equal the far is the 35 divided by the near is another 35. That means 35 by 35 will equals 1. And this is the solve of the problem. Now I'll share the screen for another point. We'll go to another page. Problem solving involving proportions. We will take the steps, like we'll do it based on the steps, but I want you to understand it, like how we will work on it. Look at this example. If your car can travel 385 kilometers on 35 liters of gasoline, how far can it travel on 24 liters? Okay, simply we'll put it in this proportion by this way. Here 385, this is the 385 divided by 35 liter, here it is, will equals the unknown is how many kilometers for the 24 liter. Then I will consider n for what I want to get or what I want to know. Then I will say 385 by 35 liters equals n, which is unknown, by 24. Then it's very easy. N by 35 equals 38.5 by 24. From there, I will bring the n. Let me just see first what I will do. I will solve it in the board. I want you to do the same thing in the next examples. Let us go to it and see. Let's take the data, then I will stop sharing the screen and go for this. If your car can travel 385 kilometers, 385 kilometers, by the use of 35 liters of gasoline, 35 liters of gasoline, that's fine. Okay, how far can it travel on 24 liters? So I want to, the 24 liters is known. but the number of kilometers, I don't know. This is unknown. This is unknown. I don't know it. So let me share the screen so that the board will be clear for you. Stop sharing the screen. Now I will say the problem again. My car can travel 385 kilometers for 335 liters of gasoline. I want to know how many kilometers it will travel. How many kilometers it will travel. I don't know this. If I put 24 liters of gasoline, it's very simply, if I said 300, when I said the solution, 385 divided by its 35 will equal. Now, the unknown is the kilometers. It's unknown. It's n. Let us give it the simple n. Divided by 24. That's fine. So, that means when I do the cross multiplication or the cross multiplying, 35n, then let's say 35n will equals 35n, this one, 35n, will equals 24 by 385. Then n, which is a symbol for the numbers of kilometers, will be the far divided by the near to the m. The far divided by the near to the m, to the n. So that will be 24 by 385 divided by 35. Then this will give me the number. If I did it with a calculator, it will give me the number which will appear in front of us now on the screen. Okay, that will give me 264 kilometers. So this will give me the final will be 264 kilometers. 264 kilometers. As you see here, this is the only unknown number, 264. Again, from the monitor here in front of you, you can see it now. If I travel 385 kilometers with the use of 35 liters of gasoline, okay, I want to know how many kilos I will travel if I will use only 24 liters of gasoline. So it will be 385 divided by 35. Those proportions, those two proportions apart, equals n, which is the number of kilos, which I don't know, divided by the number of liters which I put in my car, which is 24. Then I will do multiply cross multiplication, cross one, which is n, like the Caesar, which I said n by 35 equals 385 by 24. Then n will be this number. It will give me 264 kilometers. That's great. Same idea. In this example, I will just give you 5 minutes to check it out and solve it. It's the same problem. Also, I will do the same thing like I did in the past one. I will give a pause and we will go for it. It's the same idea. Okay. Here we go. Also the same solutions for this problem, such a problem, the same thing. I have three variables and one variable is unknown. I have three variables are known and one variable is unknown. The same solution and the same solve of the problem. Of course, I will take one or two examples from this and I will put for you in the assignments, in the next assignments, which you will do as a homework and get it back to me. The basic percentage problem, this is a new uh, a new class. We'll take it by the next video. Thank you for watching. Please go for the examples. Anything, you can reach me by the email, or you can reach me through the school, Google School. Any need, any help, if you need any help, just call me back. Thank you so much. Thank you. You have a good day. Thank you. Bye-bye. Welcome back, my dear students. This is video number 4, and we will complete what we were talking about in this area. Today, this is about the new number. If I say as example, 80% of 500, let's go and check out. If I say as example like this, I'll share the screen for 1 minute to show where I am. Then, yeah. If I say like this, 80% of 400, can you see it? 80% of 400. Let's look at the board here. It's a very small example, but it shows us something. I'll stop the share. Okay. Now, if I say 80% of 400, that means simply 80%, it should be written 80% like this, or it should be 80 by 100 divided by 400. Okay, this is how it looks like. So this will be 4 by 80, 320. So that means 80% of the 400. 80% of the 400. So I'll say 80 by 100 divided by 400. Just I will move the percentage and put the multiplication sign instead of it. And of course, 80% means 80 by 100. Okay. Now, we'll go back to share the screen and look for another part. Okay. This shows me how to complete computation with commonly used percents. Like 25%, when you send it into 1 by 4, or 1/4, half, 3/4, okay, and etc. The same thing. Many of more commonly used percents can be converted into fractions. I mean, it will be converted into fraction. As example, when I say 50% means half. When you say as example here, look at this. 50% equals half. When I change a percentage, this is a percentage, I will change it into fraction. So a percentage, I will change it into fraction. That's how it looks like. And like when I say, this is an example, I want you to do one like it. If I say any example, 5 by 8, this one in front of you, 5/8 of 4440. I said before, just remove the sign of the percentage and put the multiplication, and that's it. So 1 by 8 of 4440, it will give me this amount. It's 44.40. It's 44.40. Then the same way it is when you say 20% of $100 means 20%, 20 by 100 multiplied in $100. Same idea. You will take the amount and multiply it. That's it. Okay. Here is the finding a rate percent. How to get the rate percent? Okay. Now I will change from fraction into percentage in this case. As example, I'm gonna stop sharing here and show you an example of mine that will be easier. When I say, now this time I'll change from percentage. When I say, as example, 10 out of 20, that means 50%. 10 out of 20, that means 50%. Simply the idea that I change from this into this, or to a fraction, or from a fraction to a percentage. It's the same idea. Change from to percentage to fraction or the opposite. Now, let's share the screen back and go for another example. So, here we have the percentage number. Look at this. Let us see this example. View, let me multiply 200%, then we'll go. What number is 25% of 84? Okay, here we go. You will multiply the 25% by the 84. And this is, we talked about this before. Let us see here. Look at this. 25% by the 84. So what's the number? We will say the number as example is x. Then we'll have 25% of 84. What I will do is I will remove the sign and put the multiplication sign. That's it. 25% is quarter, 1/4. In 84, then it will equals 20. And you have a lot of examples the same way. You can have it and you can do it as well. Yeah. Let us see this here. This is telling me the variable cost of a monthly sales is 48,600, amounted to 30,375. What is the, I think I have to reduce the zoom so it will be clear better. Yeah. He's saying here variable costs on monthly sales are $48,600, amounted to $30,375. What 30,375? What is the variable cost rated based on the sales volume? Okay, then I will put the variable costs and the sales volume. The sales of, this is the sales volume of 48,000. It will be down. And the variable cost is 30,375. This will be on top. Then this will give me the percentage or the rate. Okay, so the variable cost here, let's see. Let's write the data, then I will solve it to you on the board, that will be fine. The sales is 48,600 dollars, and the cost is 3375 $33,755. So let me stop sharing so that this will appear to you very clear. Now the sales, this is the given, are 4,860, while the costs are 30,375. He wants the rate of the costs into the sales. The rate of the costs into the sales. Then I will say the rate of what? The costs into the sales. I will take the cost, it will be 330,375, and I will divide it by the sales, which is 4,860. Then I will check out with the calculator how this percentage will come to me out. So, like here, this will be 62.5%. When I do it with the calculator, it will be 62.5%. 62.5%. 62.5%. This number here, this number, 62, and when I divide it by the calculator. And that's the idea of the application of how to solve the problem of the percentage. Okay. Those are another examples with solutions. So you just train yourself on doing these examples. Then I'll stop this video here, and we will talk about the problem of the decrease in the next video. Thank you so much. Welcome back, my dear students. How are you all? I wish that you all are very good and enjoying your time. This is video number 5, and we will complete based on what we stop for the slides, which we stop on, and we will complete from there. We will go from there. So let's first share the screen. Okay, then we will have now this slide number 27. Slide number 27. Please bring it. I need you to have a paper and pen, because all our assignments will be from these exercises as well. I'll put the assignments or similar to it exactly. It won't be more than what we take here in the class. Okay, let's see this one. If 15%, okay, if 15% blended sales tax charged on the regular selling price of a computer. So now we'll say that the computer price is unknown because I don't know the computer price, but I know that the selling price is including 15% that comes into $201. This 201, it comes to $201 again. He told me in the example here, this example where the prompt is signaling to now, pinpointing, 15% blended sales tax charged on the regular selling price of a computer sold in Halifax, Nova Scotia, amounted of $201. So the taxes are $201. Let's say taxes are $201. That's fine. Then we'll say taxes $201.5. And this is, but the computer price itself, we don't know it. We don't know it, it's unknown. Same, meanwhile, the taxes represent 15% of the computer price. So the taxes, these taxes are 15% of computer price of X. which is the computer price. So now it's very clear that I have the three variables which I need here. The taxes are 2015, the x, which we said, the computer price, we don't know it, but the taxes are 15% of x. The taxes are 15% of the computer price. So what is the computer price? Let's go. I will stop sharing for the moment so the board will be clear in front of you. Then we will go to it and see. Okay. Then solution. The meaning that the computer price, when I say 201.5, solution like this, 201.5 equals 15% of x, which is the computer price. Then I want to get x. What is x? X will be, we said, the far divided by the closer. The far divided by the closer. Then x will be 201.5 divided by 15%. Now I know that 15% is equals to 15 divided by 100. It's the same. Or it is like this, 0.15. All are the same. 15% equals 15 divided by 100 equals 0.15. All are the same. Then I will say this is divided by 0.15. That will give me the result of the example which you have here. The example which you have here. Let's share the screen back. Okay, here we go. 201, like you see here, 201.00 divided by 15%. Then the price of the computer, when I do it by the calculator, it will give me $1,340. $1,340. $1,340. And this is the solution of this example. So I wish by this way, like it's a very direct, you will get something similar to this in your assignments and in your next quizzes. That's fine. Let's go now to slide number 28. Here are examples of the things which I refer to in this class, like 1, 2, 3, A, B, C, D. It's an example of every one of the issues which we discussed before. And this is also, so I will choose for you some of those that you will do it as your homework, and some of them will be in your assignments. Now we will move into the next, let me share the screen. Example. Like you see here on the slide of page 31. We have here an example. I just don't want you to bother yourself with writing the rules as a specific. It's okay. The only thing is that the rule will help you when you understand it. As example, the problem, this is the title of the subject which we're talking about, is problems involving increase or decrease in numbers. So when I say the new number is the old number plus the percentage of increasing or decreasing, that's the point. The new number is the old plus the increase or decrease in the number which we were working on. Okay, that's fine. Let's see an example here. The original number is telling me answer each of the following questions. We'll take number 1 and I will leave for you a time to do number 2 and number 3. Answer each of the following questions. 36 increased by 25% is what number? So what is the number? If the original number is 36 and the increase is by 25% of the number, so what is the real number? How it looks like? Okay, what's the new number? What is the new number? Then I will stop sharing the screen and go back now. I have my data 36, the origin, and 25% of the 36. Okay, I will stop share and go to my example. Right. So now the data given is like this. The old number is 36. There is increase that is 25% of the old number. So new number will be equal the old number plus the increase percent of old number. The increase of the old number. Okay, then the new number, I signal for number with this, okay, will equals the old number was 36 plus the 25% multiplied by the same old number, which is 36. You do this with the calculator, and we said that 25% equals 0.25 equals 25 divided by 100. The three figures are the same. That's fine. So this is a whole sum alone, 36 plus 25% by 36. This will give me, if you do it with the calculator, this amount alone. So this is amount alone and this is amount alone. You finish each of them apart. You don't do, as example, don't do 36 plus 2. No. You will do this 36 alone like this. Then this is a whole sum. You have to finish it. Then the output or the result you will add here. So this is when you multiply 36 by 25%, it will give you 9. Then this all comes to 45. And this is the final solution for the exam, for the point, 45. This is how it works. And I want you to work on it by the same way. That's fine. Okay. Screen share now. Then we'll go to our next page, which is 32, slide 32. In slide 32, finding the rate of increase or decrease. we'll check out what is the rate of increase or what is the rate of decrease in any amount we have given. As example, we will say the old, okay? We have here an example in a increase which the difference between 15, the original number was 15, and 20 is the number after increase. So we have the number after increase minus the original number before increase. We'll divide it by the number before increase. So finding rate of increase, I will write for you down how to get the ratio. It will work like this. New number increase will be with positive. Decrease or decrease in negative will equal new number minus old number divided by old number. That's how it will work. So the new number in this example, it is 20. Minus the old number was 15. I will divide this by 15, which is 15, the old number. So this will comes to 5 by 15 means by the calculator, when you divide 5 by 15, it will give you 0.33, which is 33%. You can move the decimal point and put the percentage point. Okay, so the new number minus the old number divided by the old number. Then you will calculate, put it in the calculator. It will give you a decimal as example. If it give you a decimal 0.33, 0.33, like we said, equals 33%. You will just remove the decimal point and put the percentage. You remove the decimal point and put the percentage mark or figure. That is how this example works. We use this actually for some commercial appliances like most of the commercial applications actually use it. Like if I check out the increase in prices, if I check out if there is inflation or deflation in the prices, whatever, or anything that moves, and I want to see how far it moves, like, okay, when I compare the basics and to see if there is increasement or decreasement. That's how we use it. So here I have on the slide on page 33, I have an example for you. It's the same one. I just want you to solve number 1 and solve number 2. They are saying the same idea, which I just illustrated just now, or demonstrated just now. It is saying answer each of the following questions. Christie's present have increased their contribution to our education saving plan from $125 to $425 per month. $425 is what percent? More than 125. So he wants to check out how far is the increase or the decrease. Okay, is the 425 more than 125? How far? Like, how far the increase in percentage. So like we said, we get the amount of change. So the new one is 425 and the old one is 125 divided by the old one. So 425 minus 125 divided by 125, like you see the old. This will give me 2.40. We said before that we can move the decimal point. Check out how far the numbers are from the decimal points from your right hand. We have two numbers, then it consider like I will move the decimal and put the percentage 240% equals 200. The same thing. It's exactly like you multiply by 100. 2.40 multiplied by 100, it will give you 240%. Second one is the same one, so I will leave it for you guys to do it. Okay, guys, let's go now to this example, which I will demonstrate to you. This one here is another idea of the percentage applications. Let me share the screen so it will be clear for everyone. Okay, here we go. He's saying that Ravi wants to pay off his student loan within the next 3 years. So he has increased his original weekly payment by 60%. So he was paying, as example, 100%, which is X, plus 60% of X. Now again, he was paying, as example, we don't know how far he's paying, because he said his new payment is now $88, but we don't know the origin amount, what he was paying at the origin amount. So here we go. I will just put it on the board here, the data given, then we will go for the solution. And he's asking, how much was his original payment, like you see here? How much was his original payment, like you see here? That's fine. That's fine. So we don't know how much he paid. So this will be X, the origin. The origin will be X. That's fine. The origin amount will be X, right? Okay. And he's now paying X plus, which the original amount which he used to pay, plus 60% of this original amount. So now he pays the origin, which is X, plus 60%, which is 0.6 of X. 60% of X. Okay. Which comes now to $88. This amount comes to $88. I think I will change the pen. So the origin back is X. The origin. We don't know the origin. But now he pays the origin X plus 0.60%, which is 0.6 of the origin amount, X. Okay, let me stop sharing the screen and we'll see it on the monitor. That will be fine. Right, guys? Okay. Again, this guy was paying X from his loan, or support, whatever he was paying X. Now he increased his payment. He's paying X plus 60% of X. He's paying the same amount X plus 60% of the same amount. Okay, so the X and 60% of X, the same amount, So all his total pay now is $88, right? So we want to get X, which is the original amount. That's fine. It's very easy. I would say X plus 60%, which means 0.6x equals $88. So if I want to get 1.6x equals $88, because like you say, something and 0.6 of the same thing, so they are all 1.6. Okay, here is 1 but hidden, 1x plus 0.6x, so both of them are 1.6x when you sum up them, because there is addition here. Okay, then 1.6x equals 88. Then x alone will equal the 4, which is 88, divided by the near or the stuck one, which is 1.6. So that will give me, if you do it with the calculator, 88 by 1.6. It will give you the amount. After doing it with your calculator, you can see the results here. The result will be $55. $55. That's the final output or the solution. 55, of course, $55. And this is how it works. This is how it works. Okay, same example, the examples are the same thing. Other examples are, we use it in the commercial appliance applications and the practice of life, the same thing. Let's go to the other slide. Same idea we have on this page and the next page. I'll stop for a few minutes for you guys to have this as a solution. Please solve it to me. Don't look at the answer, just look at the question itself up. Then after you solve it and get out the solution, just compare your answer with the answer which is here. Okay. On the slide number 35, I am talking. The second one. What sum of money increased by 175% amount to 143? Okay. Okay, it's the same idea which we talk about. Exactly. Nothing more, nothing less. Okay. Okay, guys, you got the solution? We have the solution now? That's fine. Okay, let's go now for our other example. We'll move on to the, I will share the screen because this part, it's your turn now. So I need you to solve the following questions, like, we'll see it here before we move to the other new part. Here are some, this is the question which I was asking you, which we did. The one which I was telling you about, 420, 5 after increase, and you want to see how much is the amount. So the new minus the old by the old. New is 425, the old is 125. New minus the old, this give me 300 by the old, which is 125. So the next pages are the same idea. We have here the one of the finding the original amount. This is the one which I soluted for you just now. I did the solution. And I said this page is including the same ideas about it, the same things, the same ideas. It's not a new one. Here we have some examples like from the exercises of the chapter. Please go through it. Take from 1 to 4 and check out the results with me. But it's not an assignment. It's just for your hand to work on it. You have paper and pen. You will do it after the class as a homework, and you don't need to show it to me, but just we'll discuss the results of it. We have some problems involving the percent. This is a summary for what we have been talking about in this chapter. And then after that, we will move to the commercial applications in the next part. By the next part, we'll move to the commercial application. But before this, just to see with me. So this is as example, exactly what we had before. So the percent increase did Neil worker receive in the bi-weekly? Bi-weekly means every 2 weeks salary from 800 to 920. That means he increased. The new amount is 220 minus the old amount is 800 divided by the old or the original amount. So it will be 920 minus 800 divided by the original, which is 800. So it will be 120 divided by the original, which is 800. So he had increase of 15%. And I told you before, 0.15 equals 15%. It's the same. It's the same. Okay. Now the next example is the same also. It gives you an idea. I just want you to go through it and solve it, and we will check the results with yourself because it's having here the solution. This is some of the problems, commercial or real life, what we get use benefits of what we talk about is how to use it in real life situations. And this is why we use the math in business in general. That's in general, why do we use the math in business? So an electronic calculator market 39.95 in Ontario's bookstore. That's fine. So you went to buy a calculator, the price of it is $39.95. $39.95. Is subject to HST. The HST is the taxes in Canada. Here we say HST is 13%. Harmonized sales taxes, they call it harmonized sales taxes. It's the abbreviations H for harmonized, S for sales, and T for taxes. What will it cost you to buy the calculator? So now the price is before the taxes is 39.95. Okay, but still we have 13% taxes. So like you see here, like we did before, the origin plus the percentage by the origin. We had an example like this. So 39.95 plus the 13% of the real price. So I will do this alone again, 39.95 plus, when you multiply 13% by 39.95, it will give you this amount, 519. Then all the amount after tax will be 95.41. Okay, please pay attention to me on the board. Let's say I bought a fan for $100. Okay? And the taxes, the HST, the taxes is 13%. Then how much is the total which I paid? I paid how much? Then I would say what I paid is the principal, the origin, the 100, plus the taxes. Taxes are 13% of the 100. Again, it's the same example which you have just now. So I will pay $100 plus 13% of the 100. So that means I will pay $100. I will pay $100 plus $13. 13 by 100 will give me this amount, 13. Then all I will pay will be $113. And that's it. So this is how it works. Okay, guys, let's see another issue for today about the commercial appliances applications, and how do we do the commercial applications for this part. Second one is the same idea. It's having the same idea, so you don't need to worry about it. Okay. This is also regarding the cash price, market price plus HST. So it's the same idea of the previous one. You have here some examples. Okay. You have here some of the examples, like which is regarding the same idea. So we don't need to worry about it. It must be sometimes, it's not always increasing. Sometimes it might be decreasing as well. So as example for the deductions, it might be decreased. Okay, guys, here we'll just go to end this part of today. It doesn't mean always it's a matter of increase. Sometimes it decrease, not increase. However, this does not make no sense. I mean, it's the same principles will be applied also in the case of decrease. But the only thing that you will have a minus in the percentage. If you have a decrease in a percentage, you will have a minus. So I want you to go like to solve this one. When you see here, it's increasing, like unit sales for August were 5% more than for July. If August unit sales were, this is the sales in August, what were the July unit sales? Okay, here we will go, we'll say that this is the July's one plus 5% of July equals August, which is 76020. So I will do this like I will take x plus 0.05x will be 1.5x will equal the selling of the price of August. Then x will be the price of August divided by 1.05. Then it will give me $72,400. So look at this. Here the amount decreased, but it makes no sense. I mean, it's only just numbers. And see, because in July, the prices were less than August, like he said in the example here. Just try to do it with your hand. You will get more understanding for it. And here also some examples for you to apply. Here also those are applications. Please tell me if you find any difficulties, but all this we have solved it before. Like the GST and HST are the same examples, the same principle, the same ways you work on. Yeah, here is some exercises for you to go through. You can check out. If anything you misunderstand or you don't understand, please come back to me with the number of questions. I will send you the solution of it, or we'll discuss it. Okay. Here we're talking about the currencies. And the currencies is a relationship between a currency of one country to the currency of another country. As example, when you see, look at here, you will see the Canadian dollars into the US dollars, right? Okay. So the Canadian dollars into the US dollars, and here is the relationship between both of them. So the Canadian dollars is 1.2473. The US dollars is the one with the basic, we've considered the basics. So this is the relationship between them. It means that the increase exchange rate for converting US dollars to Canadian dollars. Okay. And here how it works for them. We will discuss this in the next class, but just I'm telling you what about it just a little bit so that we will discuss it with examples on our next class. Shall I stop here for the moment and we'll complete on the video, the next video. Thank you so much and have a great day and take care of yourself. Bye-bye. Welcome back, my dear students. How are you all? I wish all of you are doing well and enjoying your time. Yes, I have received that there is a repetition, like is repeated, video 1 and video 3. Actually, there was a video from the half of it. It was like I just kept the board. I thought I put pause, but I didn't pause. So it continued like wasting a big part of the video. For that reason, I cut it and re-upload it back. So this is the problem. If it is, it's like, yes, it's repeated. But in the next, on the following videos, I will give more examples about the proportions. I will assure on some points which is considered very important for you as well. Please don't hesitate to contact me if you didn't understand, if something is vague, like something is not clear, if you need any questions regarding anything, if you have some ideas, like as example, maybe like the board is not enough or not big behind me, I'm trying to do my best. Just if the handwriting is something, don't worry, I don't get angry or upset from my students because you guys are like my kids. But I welcome any feedback. Whenever there is a feedback, you are very welcome. Our next week, we will have also a big class about this, and I will upload some videos for the next week. So you just see the videos very well, see the PowerPoints, the slides, Look at the book of the college, and just you will have examples, semi or exactly the same which we have here, almost like what we have here. Please don't copy and paste answers. It's in math is not that much because it's in other subjects. Some students copy and paste. No, please don't copy and paste. I need your mind to work. I need to see your rule of thumb, the way you are working, how you are working, not only in math, also in management and any subject I'm teaching, either in the college or in other colleges. So this is what I want you to do. Today, this video is regarding examples only. It's a general review for the proportions and ratios. And this is a very important video for you as well. Of course, I will put also another videos from the YouTube that will help you to understand what the meaning of proportions and what the meaning of the ratios. And the problem is not in the proportions and ratios only, no. How to apply it, how to apply this work when we are working in commercials applications, like in business, how we can get benefit of the proportion and the ratios, how we will get benefit in business from this work. Let's go today. Let's go for the slide 38 first. I will share the screen. Let me share the screen. Then, yeah. Okay. Let us go to the page 38 on chapter 1 and 2, which you have here in this thing in the in your notes, and let's go and see, check out how it will work, like what we want from here. So he's talking about, as example, let us see this example, and let's take what's in it, like the data which we will use. He's saying what percentage increase did Nerd Walker received, this is the name of a man, receive if her bi-weekly, she's a woman, her bi-weekly salary rose from 800 to 920, from 800 to 920. Okay, to 920. Okay, so I need to know what is the origins. What is the origin? The origin was 800. Let us see here. The origin was 800. The origin salary was 800. That's fine. Now this 800 become to 920. Becomes 920. I just want to see the percentage. How much now did it increase? Okay, let me go to the solution. I will put the stop the share now for the moment, so you can see this, the board behind me. Now I think, what is the percentage of increase like? Okay, the old, let us say the old was 800, the origin. Now I was taking $800. Now I'm taking $920. How much is the increase? Then I will count the increase or the decrease. Increase equals the new minus the old. So 920 minus 800, that will give me $120. Okay, that's fine. Then for putting the percentage of increase or decrease, percentage of increase or decrease, that will equal the size amount of increase or decrease, which is 120, divided by the origin amount, So I'll check out 120 based on the origin amount, how much it is. Then I will see this in percentage. That's fine. Okay, that's fine. So you see here, it's now 120 based on 800, 120 based on 800. That will give me 15%. It will give me 15%. Actually, the second example is the same as the first example, number 39. Look at this. Expenditures of government program were reduced from 75,000, okay, to 60,000, right? What percentage change here? Actually, it's the same one like the one before. The old minus the new, or the new minus the old, divided by the old. This is how I will get it. I will take the data here as well, but I will put here the sign minus because I need to put the sign minus. Anyhow, I will stop the screen. I will stop sharing so that the board will be clear for you guys. And actually, I like this way because the students will understand more. Here is the board. So the example was 76,000. The example was, the amount was 75, the origin was 75,000. Let's see, the origin was 75,000. And the new amount is reduced into 60,000. That's right, great. And I want to know how much is the increase or the reduce? How much should be the increase or the reduce? That's fine. The old amount was 75. The new amount is 60. Okay, okay. That means that if I say the new, let me go on the rule like this: new minus old or origin. Let it be simply like this so that you will understand it. New minus origin on divided by the origin. So the new is 60,000 minus the old is 75,000 divided by the old, which is 75,000. Some students say, hey, he didn't do it like this. He did the nomination alone and he did the denomination alone. Why you are doing all in one step? I just want you to understand that the rule here is the new minus the origin based on the origin divided by the origin. So here will be minus 15,000, but minus. Why minus? Because it is reduced from 75 into 60. It is down. Divided by the origin, which is 75,000. Then you will tell me, but the book in the example, there is no minus. Minus is telling you the direction. So from the minus, you will know, did it increase or did it decrease? This is how the minus work. It's working for that reason. So you will tell me, okay, I will go on the answer of the book or your answer. It's both are the same if you do this. But the signal of the minus shows that the amount is decreased in this case. Okay. So when we divide them, 15 by 75, it will give me 20%. Okay, then it will give me equals, let's see, equals minus 20%. You will tell me, hey, what the minus? Because minus by positive will give you minus. That means that the expenditures, the governmental expenditures is reduced, is down 20%. Mean the government reduce its expenditures on the people 20% down. Okay, the minus signal, this minus. Okay. Let's go to flip to the other question, which is on page 40 actually, and go there. I will share the screen back and go to page 40. Page 40, slide number 40. Slide number 40, this was 39, okay? We have something in 39. Yes, we have something in 39. So sorry, we will bring 39 and check what's there on 39. Let's see what goes on 39. I had an example before like this, and I will repeat it back. An electronic calculator marked 39.95. So the calculator's price is $39. It's $39 minus 0.95. This is the real price. In an Ontario backstores in its suburbs, 13% HST, 13% HST. The HST in Canada, because you guys are, maybe you don't know, the HST is the taxes. This is the taxes here. It's almost like 13%. Okay, so you pay taxes for anything you will buy here. Like if you will buy anything, you will pay this 13% taxes. It's called HST. Okay. Harmonized sales taxes, and this is harmonized sales taxes. So H for harmonized, S for sales, and T for taxes. Okay. What will the cost be? The total cost. He wants the total cost. So the total cost, all the costs which it's logically, you will pay, this is the origin plus the tax. Okay, so you will pay total equals, let me make the screen stop share for the moment so that the board will be clear. Here we go back. We said the price of the calculator, which you will buy, is $39.95. Okay, and you will pay as well, plus the taxes, which you will pay. So both of them total will be the price plus taxes. That's fine. Plus price plus the taxes. That's fine. Okay, then this will be, the price is $39.95. It's the price plus the taxes. The taxes is 13% from the price. So plus what? 13% of the real price, which is $39.95. Look at this. The price plus the 13% of the price, 13% of the $39.95. Okay, so this is the total price. When you finish this operation, how you will do it? You have first to multiply 0.13, which is 13%, 0.13, or 0.13, by 39.95. Then, after you finish this operation, the multiplication, you will add the sum, the output, with 39.95. So the priorities of the transactions. First, you will finish the multiplication first. Then after that, you will go to add this into the 39.95, and this will give you the total sales price, which is, I believe it will be 45.14. 45.14. 45 equals equal 45.14. And this is how we will solve this question. I hope that you get it, understand it, guys. Now we will go to share the screen to check out another example. You have example, I want you to do this because it's exactly like the one before. Exactly the same idea and the same idea that it's a part of the taxes plus a part of the taxes as well, the price plus the taxes. Let's go to page 40. Okay, that's fine. We'll check out page 40. I'm sorry for the time is wasted in this, the slides, to enlarge the slides, but it's okay anyhow, as long as you understand, that's fine. Page 40, number V, that's fine. So number V is telling me the consumer price index of July of this year was 125, which is 120% of the appendix of 10 years ago. Okay. What were the index 10 years ago? That's very nice. Now he's saying the consumer price index of July was this year was 125. Let's take the data here, then go for solution. Okay, the consumer CPI, the CPI, we call it consumer price index of July this year was 125. Great, 125. Okay, and the CPI is indicator for the prices, for the movement of the total prices of a society. It's mixed, a mixture of the whole prices of a society, how it's moving like. Okay, the consumer price index in July of this year was 125, which is 120% of that of 10 years ago. Okay, that equals 120% of 10 years ago. I will give a simple for the one 10 years ago with the example X now. So he wanted to know what was the index 10 years ago. So he wanted to know X. Okay. He's telling me this year, this is the CPI this year, or July this year, CPI now, let us say now, was 120x of 10 years ago. So X means for, it's a variable, which because we want to know what is the X then. Okay, 10 years ago. Then I want to know what was the CPI. This is the CPI 10 years ago. We make it with this thing X. Okay, I want to know the X. How was the CPI 10 years ago? How was it? How was it looks like? Okay, I said before, I need the variable. I just need this variable. So X, which is a variable, equals the far is 125 by the near is 120. Again, the far, which on the other side of the equilibrium, when you pass the equation, 125 divided by the near, which is 120. Okay, that's what comes to. Let's see in the example how it is. The result of it is, okay. Would notice that I just want to show you something. This is 120%, like we said, 120%. How will I get rid of the 120%? 120, when you say percent, means by 100. Again, 120% is like this. So when you divide it, it will be 1.2. It will be 1.2. So let me do it back in front of you totally from the start itself. I know the board is small, but we try our best till I change this board with a long one, with a big one. Now, first of all, he's saying 125. Now, the CPI now is 125. This is 100 equals now equals 120% of the CPI from 10 years ago. This is CPI 10 years ago. It's fine. Then I want to know how was the X or the CPI 10 years ago. Then CPI or X 10 years ago equals 125 divided by 120%. The reason I did this, like I'm telling you, when I want to do the X, get the X, which is symbol for the CPI from 10 years ago, will equals the far divided by the stuck to the variable. Okay, so now I want you to know what is the meaning of 120. We said this before, but I will repeat it back. I will repeat it back here in this piece. 120% equals, we can do it like this, 120 by 100. Okay, that means it will come to, when I move the zero with the zero, or you can do it with the calculator, it will give you 1.2. It will give you 1.2. So X here means 125 by 1.2 equals, this equals, let us see the final result will be what? The final result here will be 104.2. 104.2. 104.2. So what do we mean by 1.402 here? What do we mean by 1.402? This number. 1.402. This number. Okay? What do we mean by it? We mean by it that this was the CPI 10 years ago, which I'm looking for. The CPI from 10 years ago. Okay. That's fine. This was page 40. Let's go to another example on page 41 and see what 41 is talking about. We'll share the screen. Sorry about that. This is, it's the same idea of increase or decrease, like we had it once before, but we can repeat it here back. Solve each of the following. I will leave it actually for you to do it because it's the same idea which we talked about before. Solve each of unit sales of August were 5% more than of July. So July equals, August equals July plus 5% of July, of August. If August unit sales were 76, like this, blah, 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 because July would be like this, so here would say X plus 5% of X will equal 76,020. Then we want the X alone, okay? So I will keep the X and move that number to the other side. 5%, X and 5% means one, both of them, 1X and 5% of X. Both of them will be 1.5% of X equals this amount. Then X will be the far by the near. So it will be 76 point, this amount by 105. And this is the solve of the problem. So I just want you to do it because it's the same idea which I talked before. It's nothing new in this. Nothing new in this. So I want you to do it with your hand. And if you got any problem, just tell me. Now, the units, the sales for August were 5% more than July. Okay. Okay. Then if August unit sales was 76, this is including X plus 5.X, 5% of X. Like this, I will say like this. The sales of August is the sales of August were 5% more than for the July. Okay, then August is X plus 0.05X. This is August. Because he's saying, and this amount was 76020. This amount was $76020. Let me stop sharing. So that the screen in front of you. Okay. X is July. Let's see. X is July. And August is July plus 5% of July. I want to know, what about July? I know about August. So August is 76020. Okay, then what I will do here, again, let me do it in front of you, but I need the data on one side, 5%, and I will do it back. Let's see now. Simply, he's saying this is August sales. August sales is 76020, okay? And August sales equals July sales plus 5% of July extra. July sales plus 5% of July extra. Then August sales will equal X plus 5% of X. X plus 5% of X. Okay. Okay. Then August equals 1.05 X. Okay, I have August already. I have already August, which is $76020 will equal 1.05 X. Then X will equal the far by the near, 76020 by 1.05. Then it will equals, the amount will equals like what we have here. What we have here, it will be 72460. 72460 dollars. And that's how you would solve it. It's very easy and very simple, and an idea, a same idea of what we talked about before. Now we'll go to another idea, which is in 41, and about the currencies we're talking here. I will share the screen now for you guys to see. Okay. So this is properly the relationship between, as example, the Canadian dollars and the US dollars. So if $1 US equals 1.247 Canadian dollars, you can use the converter. Like if I say $100, Americans will equals 100. If I say as example, let's go like this. Let's say that $1 will equals 1.724, 1.247, 1.247 Canadian, CDN, Canadian dollar. Okay. If I want to get $100, if I want to say how much will get $100, 100 US dollars, you guys all know this, US dollars will equals 100 divided by 1.247 Canadians, which will be move the decimal point because this is 100, 2 digits to the right, 124.7 Canadian CDN. And that's it. It doesn't help here so much. I don't need this so much now for the moment. But actually, I need it on the next advantage, on the next point, which is the appendix. I will show you the appendix. Page 46, and that's what I need. Yeah, this is very important page, please. I want you to know it, and because you might get example, or you might get it as a question target. So if the questions, by the way, of the exams and the assignment, it will be the same ideas which we take here. We won't bring something so far or so complicated, only just with changing the numbers. But others, all the questions which I'm giving you here, is the same exactly, no more, no less. So this is slide number 46. Yes. Okay. If I want to get, as example, look at this now in front of you on the screen, and it's in the book as well. So you can get it from the screen, from the slides. Just enlarge the slides. I'm sorry about the slides because it came to me like this. So what you will do here is just enlarge this slide so it will be appear in front of you, because if you get it in the exam or in assignments or quizzes or whatever, or home assignment, the same thing with a change in the numbers. I won't change these numbers, but I will change to you the numbers in the exam. Like what is example? First, to find the exchange from the Canadian dollars into the Swiss francs. You know what you will do? Let us see an example. You will go like this on the column till you get the number of the Switzerland. Then you will, okay, let's see. As example, I just want to enlarge it more than this so that it will be like you guys can see it very clear, the numbers, because I need the numbers to be, yeah, okay. Now like this is very clear. First, find the exchange. He is saying locate the Canadian dollars column in the table. That's fine. Move down to the Canadian dollars. Like this, I will move like this way till I come to the what he needs, the Swiss. Okay, here we go. If I want to get the conversion of convert 55 Canadian dollars into Swiss francs, okay? Convert 55 Canadian dollars into Swiss francs. So, like I told you, what we will move here in the Canadian dollars, till we come down into the Swiss francs. We will move in the Canadian dollars till we go down to the Swiss francs. So, I need 55 Canadian dollars. Okay, don't move this way. You move vertical, like the column from up to down. I need what I need from Canadian dollars to Swiss francs. So I move like this from Canadian dollars to Swiss francs, where they intersect, where they meet each other, here. So from Canadian dollars into Swiss francs. That's it. I need to change 55, 55. Look at the prompt here. 55 Canadian dollars into Swiss francs. Okay, the convert is how much? The convert factor is 0.7545. That's fine. Then to finish this, it's basically depends on the schedule. So you have to be very aware of how you will work. Otherwise, you will make a mistake. Again, I'm saying, let me repeat it back. To convert from Canadian dollars into Swiss francs, I will move vertical, like a column, up to down. Canadian dollars into Switzerland, the Swiss francs, which is this one. Okay, 55 divided by, or applied by, it will be 55 Canadian dollars, 55 Canadian dollars will be multiplied by the coefficient variable, which is 0.754. 0.754. 0.754. You can add a 5. This will equals the amount which he gave me here, which is $41.5. $41.45. $41.50. Sorry about that. $50. So I will stop share. Here to appear on the screen, I move down on the Canadian dollars till I meet the Switzerland franc. The conversion variable is 0.754. The coefficient of converting is 0.754. Means 1 Canadian equals 0.754 Switzerland franc, Swiss franc. So $55 will be multiplied by 0.74. It will give me $41.50. So please don't forget how you will move here. Now let's go to 47 slide. I want one more. And this is also a very important one, which we need to know very well. What do we mean by the index number? The index number in general tell us the price of the movement of the prices in general. Are the prices going up or the prices are going down? It gives us the trend of the prices, where is it going? If there is an inflation, and you will know from the economic that the inflation means prices of goods and services become higher, not lower. Or if the prices come down, or the prices coming down, means it's called recession or deflation. This happened when the prices go down. So the CPI, or the Consumer Price Index, is telling me the movement of the prices of goods and services. When societies face problems like wars, like starvation, like problems, like any kind of economic problems, usually happen inflation, where the prices go up. Or when there is a recession like 2008, when everything is locked down, shut down, like I'm now in the COVID time, there is a recession. Means people are not able to buy any more goods and services, so the prices go down. Okay, so here we say the index number is this one, which is telling me we compare 2 years. As example, the price of text was the textbook was $115 in 2012. Okay, and 125 in 2017. Compare them. Okay, I will take the new divided by the old. very simply, the price in 2017 divided by the price in 2015 equals, the price in 2017 is 125.35. The price in 2015 was 115. Just divide them by each other. Divide them by each other. This 109, which is, I want you 1.09. Just remove the decimal point and put percent. Again, 1.09, because there are two numbers. There are two numbers after the decimal points. So move the decimal points, put the signal of the percent, and that's it. And that's it. Okay. Let me give an example quickly of my own. The price of a house in 2020 is 500,000. The price of the same house in 2000 was 100,000, or let's say 250,000. Okay, now let's study the movement in prices by the CPI. How it will be the change in prices, change in a percentage equals the price of 2020 divided by the price of 2000 will equal 2020 is 500,000 divided by the price of 2000 was 250,000. Those with those, this with this. 50 by 25 will give me 2. Means the price is doubled. The prices is doubled, 2 times more. It was 250,000 the house in 2000. Now it became 500,000 in 2020. Wait a minute. You said we will put percent. Yes, you will put percent. 2, when you might multiply it by 100, it will give you 200%. Mean the prices became higher. 200% means twice of the price. But in the X example, as example, if it is like this, if you get a fraction, like this as example, if the output was a fraction, as example, 1.57. As example, 1.57. Let's see, 1.57. Okay, you will remove the decimal point, then you will say 157. Then you will put the percentage. That's the increase in prices. So don't forget to remove the decimal point and put the percentage signal or symbol, and that will be fine. 2, if you get fractions, if you get an integer real number, 2, 3, 4, 5, then put beside it 2 zeros and put the percent. If you get a fraction, move to the decimal points and take the first one on the left and the 2 after the decimal points and remove the decimal and put the percentage, like I did here. Again, I would say 1.57, remove the decimal point, remove this decimal point, then put the percentage mark, and that's it. So we are comparing the prices in 2 different years. This is what we are doing. Okay, you do it. You usually do this every day in your life. Like you say, oh, this from 10 years ago, it was only $5. Now it's $10. The price is duplicated. Duplicated is 200%. The word duplicated, when it's doubled, this is 200%. Okay, Let's move on now uh, to page 49, 48. This is 47. Let's go to 48. 48. What's there in 48? Let's see. Let's see what's there on 48. It's a very important example. Very, very important example. We said the purchasing power. Please keep watching this because those are all the materials of your exams, your quizzes, your assignments, your homework. Only it will be different in the numbers. I will give you the same, not the same numbers, but I will give you another numbers and you just calculate it. That's it. That's what you will do. You will know the rules and how to calculate. And why we use the CPI, Consumer Price Index. Why do we use it? What is the mean or what do we use it for? The price, I didn't share the screen, I'm sorry for that. Yes, here now it is. I'm here now on page 49, guys. I'm on page 48. I'm on page 48. So what do we mean by the Consumer Price Index? What do you mean by it? Consumer Price Index, CPI, like I told you, it shows me the trend of movement in prices. Are the prices going up or the prices are going down? This is what it tells us. Prices, CPI is an indicator. It tells me prices are going up or prices are going down. That's how it works. Are the prices going up or the prices is going down? And I use it also for calculating something is called purchasing power. What do we mean by the purchasing power for the CPI? What do we mean by the purchasing power? Purchasing power simply means what money can buy. The purchasing power means what the money can buy. Very simple words. Okay, so let's see now. If I will talk about this example in front of me, in red here, you will see the purchasing power of $1 equals the whole equation. 1 by the CPI by 100. So welcome, my dear students. Welcome back. Because of the length of the video, so I have to cut it. Then I have to merge it back. So I apologize for this point. Now we were stopping like from the X1. We were stopping on the, yeah, here we go. On the Consumer Price Index here. And I will share the screen now, just for you guys to be aware of what I'm doing. Let's go. Okay, let's share. Yep, we are shared now. So here, like you see, this is the Consumer Price Index, and I said that the Consumer Price Index is just a measure of how far the inflation goes, So it gives me an idea about the prices is going up or the prices are going down. And the purchasing power of the dollar, which said it's simply what the money can buy, what the dollar can buy. It is 1 by the CPI multiplied by 100. Let me give an example quickly. As example here, but I will take the CPI of the year which he is talking about. Like as example here, he said that the price was, the CPI was 122.8. Okay, so I will check out this for one of the years, like 1 by 122.8 multiplied by 100, it will give me this amount. Okay, let me see. Let me see quickly what I will do here. Yeah, the purchasing power was 122.8 in 2013. purchasing power was 122.8 in 2013. Then the purchasing power became like then after that it became, okay, 122.8 in 2000, 125.2 in 2014, 125.2 in 2014. Okay, then he wants to check out if the purchasing power increase or decrease. So here we will divide to get the purchasing power of 2013. We'll say 1 by 122.8. Okay, then we will multiply this by 100. Then the result of this will come to 0.814. 0.814. That's fine. Let me stop sharing the screen and show how it goes like. See, 122.8 in 2013. And the CPI was 125.2 in 2014. And I want to check the purchasing power. So the purchasing power of 2013 will be 1 by 228.8 by 100. It will give me 814. Now, what I will do is this 4, I won't round it. So 4 is less than 5. Then it will be 81. I will remove the decimal point, remove this decimal point, and take 2 numbers after the decimal point. So I took those 2 numbers, right? Those 2 numbers. Then I neglect the 4 because 4 is less than 5. I'm rounding now. So all will come to 81%. 81%. That was in 2013. You guys do 2014, the next one. It will be, next one will be 1 by 125.2 multiplied in 100, the same thing. Okay, then here we go. If you do it by your hand, it will give you this number, 1 by 125.2 multiplied by 100, then this will give you 0.798. Wait a minute, wait. Let's see here. Here we go. 1 by 125.2 multiplied in 100, that will give me 0.798. Will give me 0.798, as you see here, as you see in the example here, in this area, here. Okay, so I will round it, means I will take 2 numbers, but here is 8. 8 is more than 5. Let me stop sharing the screen. This is now for 2014, which you suppose that you are the one who solved it. Okay, 1 by 125.2 multiplied by 100, it will give me 0.798. That's fine. What I will do is I try to round it. Round it means, I remove the 8. 8 is more than 5. Then this will be 0.80. So I don't need the decimal point, so I can say it is 80%. What happened? The purchasing power of the money was 81 in 2013, and it became 80% in 2014, means that the purchasing power of the money is down, means the value of the money is going down, means there is inflation, like. So the power of the money is down and there is inflation, such a case. Let's go now to another example, which is in page 49, I believe. Yes, on this one. That's the one which we want. Okay. This is about how to change from real income, from nominal income into real income. How to change from normal or nominal to real one. Okay. The rule here is very easy. I say that the real income equals nominal real income equals the nominal income divided by the CPI. Okay, that's mean like as example here, real income, can you see it? You can see it here on the screen, equals nominal income divided by the CPI and multiplied, of course, in 100. Will be multiplied in 100. As example, he's giving me in the example here, he's saying it was 50,000 income in 2007 and 53,000 in 2011 and 56,000 in 2014. That's nice. And the Canadian CPI was 11.5 in 2011, 125.2 in 2014, and the CPI based year was 22,002. Determine GEM's real income in 2011 and 2014. Okay. When I decide for the real income, it's the nominal income for the year which is asking and the CPI of the same year which is asking. So nominal income in 2011, his nominal income in 2011 was how much? 53,000. See, 53,000 in 2011. I will divide it by the CPI in 2011. So the CPI in 2011, CPI was 111.5 in 2011. That's it. And I will multiply this in 100. It will give me this amount, 47,533.63, right? That's right. Okay. Same thing if I want to do for the real income. Can you get it? Can you do it by your hand? Now, you want to get the real income for 2014. Wait a minute. It will be the nominal income of 2014. 2014 nominal income was 56,000, right? 56,000 a year. Divided by the CPI of the same year, which is 2014. It was 125.2. Divided by 125.2. Multiplied by 100. This will give me 44,728.43. So this is how to change from nominal income into real income. Why do we care about this? We care about this because the nominal is nothing. We don't care about the nominal. It's amount of money, paper, just paper. But the real income is what the money can buy. And this is what I care about. I care about in economic, and you will study this in economic. Hopefully this will be with me. In economic, in all the economics. We care about the real income. Please keep this in mind. We care about the real income, not about the nominal income. Again, the rule is it's very easy. I will give you the nominal income, I will give you the CPI, and I will tell you give me the real income. So you will say nominal by CPI divided by the CPI, and you will multiply in 100. Okay. So let me give you an example of mine now. Just you have an example here, and I will give you example of mine because I will stop sharing the screen. So, okay. Let's say my nominal income was 150,000, and I hope so, in 2019. And the CPI for that year, 2019 also, was 150. So what is my real income? Equals nominal by CPI divided by 100. Then it will be like this, 150,000, it will go like this, 150,000 divided by 150. This is all assumed numbers. This is not, but just to give you the example of. Then in 100, this one will go with this. Then this will be 15 by 15. This will be 1,000. It will be $100,000. So the real income is $100,000, but the nominal income is 150. And I said If I tell you in the exam, what do I put concern for? The real or the nominal? Tell me the answer is the real, because the real is what the money can buy. Thank you so much for this class, and hopefully for you all the best, guys, and I will see you in the next part, which is the equilibriums and the variables, how to get x and y from two equations. Thank you so much. Bye bye.